In this section, we're going to talk about the development process. There's a sequence to developing software. Many beginning programmers read a problem description and begin writing code immediately. This is a mistake because often the problem description is incomplete or unclear, and writing code that implements an idea that is incomplete or unclear will always result in software that's difficult to maintain, that has errors. Therefore, the proper process is to start with what's called requirement specification. That is, understand the problem. Understand it well. Don't look for a few keywords and believe that that is sufficient. Consider edge cases. These are situations which won't happen frequently, probably only under special conditions, yet they may happen. For example, if we're keeping track of test scores, an edge case might be the value 0 or the value 100. We don't allow negative numbers, and outside of bonus points, we don't allow points over 100. We need to ensure that both 0 and 100 are handled correctly. Many times software has failed at these edges, so be sure to include those in the thinking. Systems analysis is where we determine what data is needed. Many programs in this course will require just a minor amount of keyboard input, but in a larger scale, tremendous amounts of data is needed, and it can come from various sources. All of these need to be taken into consideration well before the time any code is written. The system design is the idea of transforming that input data into a new state. That new state is the point of the program. What are we going to do to the data we've just obtained? From that, we move into implementation, where we begin to write code to address the transformation of data and any other features that requirements specification brought up. Often missed is the idea of testing. Once written, many programmers early in their career believe they're finished. I mentioned edge cases before. Test data needs to be fed into the program to ensure that those edge cases are handled, invalid data is handled, typical data is handled. Testing is a difficult process for a number of reasons. The primary one being that most developers understand what their code ought to be doing, which is the point of requirement specification, system analysis, system design. If they've met the criteria of those, programmers tempted to feel accomplished, and that's probably largely true. However, many times requirement specification does not deal well with the idea of failure. Testing is a step where failure is intentional. It's brought to the forefront to stress test and verify the accuracy of all the previous steps, not just implementation. Finally, once a piece of software is complete, it is entering the longest, most expensive phase of its entire existence. That's called maintenance. That's when the program is running and then new features are added or bugs are discovered. The program has to be updated. All these steps taken together are the development sequence. For a course like this, where lab projects are small, many of these steps will be ignored. That doesn't mean they should be. At least passingly go through them, try to understand them. The more familiar you are with these steps, the better the software developer you will be.